Let's try to think about the cutoff mode of the NPN BJT in this video. In the previous video, I said that cutoff mode is happens when the both the junctions, the base collector junction, which is this junction, and the emitter base junction, which is this junction, both are reverse biased, right? So, uh, if the junctions have to be reverse biased, then we know from diode theory that now this is the N side, this is the P side, and this is the N side. So for the collector base junction, so let's say for the collector base junction to be reverse biased, what does that mean? What would the voltage VBC, what should it look like? So if it has to be reverse biased, VBC has to be less than the cutoff voltage of the junction, which let's say is something like zero point 0.7 volts. Okay. Similarly, what does the emitter base junction voltage have to be for cutoff or for reverse bias? It will be VBE should be less than 0.7 volts, right? So if you have these conditions, then you have your BJT or your NPN BJT is in the cutoff mode. Usually, though, what happens is there's a slight change because you design your collector base junction so that it is in cutoff for less than 0.5 volts or something around that. Okay, these are not exact values but approximate values. Now, how does the transistor work in cutoff mode? In cutoff mode, you can think of the transistor simply as this. So let's draw a model here for the transistor. So, so if this is the emitter and this is the collector and this is the base, so basically that would be the model of your BJT, a mathematical model of your BJT. Basically, there is no current flowing in the base emitter junction, right? Because this base emitter junction is just open, so there's no current flowing through that. And the collector emitter junction is also open, so there is no current, and there is no current between the base and the collector as well. So there is no current overall in the circuit, and this is called the cutoff mode of the NPN BJT.